Welcome to chemistry class with Christopher GK. Of course, your chemistry teacher. Today will be, in this particular video, we'll be looking at a very important element to human life and to living things. The topic is oxygen. The topic of this particular video is oxygen, and it's expected by the end of this video, you should be able to explain the electronic structure and bonding capacity of oxygen, and you should also know how to explain the laboratory preparation and industrial preparation of oxygen. In laboratory and industrial preparations of oxygen, the next thing is that you should be able to explain or list the physical and chemical properties of oxygen, and lastly, the uses of oxygen. These are the things we want to consider in this particular video, and we are going to take them one after the other. So, first of all, what actually is oxygen? How can one explain oxygen? And what is oxygen? Oxygen is the first element in group 6 of the periodic table. And it was Lavoisier that first described the major properties of this newly discovered gas, and arrived at the conclusion that the gas was essential for combustion of substances. He discovered that this particular substance is what helps combustion. Now, he erroneously thought that this gas was a major constituent of all acids and named it oxygen, which meant acid producer. Which means acid producer. That is the meaning of oxygen, what he thought when he gave it the name. However, it's an erroneous belief. But oxygen generally is the most abundant element on Earth. Oxygen is the most abundant element on Earth, and it occurs in nature in both in free state and in combined states. It occurs naturally both in free state and in a combined state. In free states, it constitutes about 21% by volume of atmospheric air. The air we breathe, the air in the atmosphere, consists of 21% of oxygen, and in the combined form, it accounts for 55% by mass of the earth crust, the ocean, and the sea. Of course, as you can see, that large percentage of the earth comprised of water. All right, comprised of oxygen. That is number one we need to understand about it. It is present in Trioso silicates 4. It is also present in oxide, both of metals and non-metals. So whenever you hear about oxide, it's telling you that that particular thing, if it's a metal, is a metal oxide of oxygen of that particular metal. If it is non-metal, it is the oxygen of that particular oxide of that particular metal, means that oxygen and that particular non-metal. Something like carbon 4 oxide means oxygen and carbon. Oxygen and carbon, or carbon and oxygen. All right, water, as one of the most abundant compound on Earth, is made up of about 88.9% oxygen by mass. So the one thing we need to understand that the body, human being, is made up of about 2/3 by mass of oxygen in a combined state. So your body, you can see, you are seeing, is full of water. About 2/3% of your body system is full of water. It's water. It's oxygen, I mean. Sorry, not water, it's oxygen. So you need to understand that the place of oxygen in every living being, in everything living, is innumerable. The place of oxygen cannot be overemphasized. So oxygen is 2/3 by mass of your body system, because nobody can survive, no living thing can survive without oxygen. All right. Let's talk about the bonding capacity. Bonding capacity of oxygen atom. How does it bond? Now, generally, oxygen has 6 valence electrons and can acquire or can attain octet structure when it receives an electron. It can attain octet structure, octet electronic structure by, number one, by accepting 2 electrons. Because it has 6 valence electrons in the atmosphere, it needs 2 more electrons in order to attain octet structure. So accepting 2 electrons from electropositive elements like maybe like metals to form negative oxide, that means O2 minus, which is the formation of the ionic compound. Example, calcium can give out 2 electrons to oxygen in order to form calcium oxide. However, oxygen can also attenuate by entering into a covalent bond formation with non-metals by covalently sharing 2 of its outer electron. It can also go into combination, covalent sharing by sharing with another non-metals. So something like this, it forms single covalent bond with 2 hydrogen atoms. 2 hydrogen atoms to give water molecule, which is like this. As you can see here, H1 single bond to the other one, the other side of hydrogen, all together 2 single bond with water. In oxygen molecule itself, that means 2 oxygen makes up a molecule of oxygen. A double bond joins the 2 oxygen atom. You can see oxygen atom, 2 oxygen atom here. Oxygen, that is 2 oxygen molecule. A molecule of oxygen is 2 oxygen bonding with 2 double bonds. So oxygen forms a wide variety of ionic and covalent compounds, and it is only element of group 6 which form multiple bonds with itself. Among the group 6 elements, it's only oxygen that form multiple bonds with itself. All right, how can we prepare it in the lab? Laboratory preparation of oxygen. One of the ways is that oxygen can be prepared in the lab by thermal decomposition of potassium trioso chloride 5 and hydrogen peroxide. When there is, thermal has to do with heat. When trioso chloride 5 is being, potassium trioso chloride 5 is being heated, it will decompose and oxygen will be released. We can also use oxidation of hydrogen peroxide. When hydrogen peroxide is being oxidized, oxygen will also be produced, or we can produce it through that. Now, other method includes the composition of mercury 2 oxide, lead 4 oxide, and the reaction of sodium peroxide with water. These are the ways in which oxygen can be prepared in the laboratory. All right, thermal decomposition of potassium trioso chloride 5 and hydrogen peroxide. Look at it. We have, this is the setup. We have potassium trioso silicates, potassium trioso chloride 5 here, and this is the setup in the lab. When it's being heated, look at the heat, and the manganese 4 oxide is being added there, is being heated, and this, you can see oxygen is being produced here. Now, that is one of the ways. Another way is that the other one I talked before, which is hydrogen peroxide, in the presence of manganese 4 oxide, when it acts as a catalyst, of course. Even in this particular one, manganese 4 oxide, you can see it in the equation here, it acts as a catalyst there to fasten the rate of chemical reaction. So here, hydrogen peroxide decomposes readily to liberate oxygen without any heating. This one does not require heating, while the oxygen gas will be produced. So it does not require heating, and at the same time, oxygen will be liberated. All right, the method is highly recommendable, is highly recommended for use in school laboratories because it is safe and efficient as it requires no heat. It is highly recommended in school. We use it often in the school because no heating is required for that. And this is the setup in which we use it. And this is hydrogen peroxide. It's being poured through the test tube funnel. This is the manganese 4 oxide there. as acting as a catalyst, and the hydrogen gas will be collected here. As you can see, it's here collected over water because it's lighter than water, less dense than water. All right. But industrially, in the industry, industry prepare it in a different way, in a cheaper way for them. In places where a cheap source of electricity is available, oxygen may be prepared industrially by the electrolysis of water. Electrolysis of what? Acidified water. That is the meaning. However, in most places, it is prepared by fractional distillation of liquid air. Now, in one of the video classes, we talked about electrolysis of acidified water. One of the products there that we recover and we produce in the anode is oxygen. So it can be gotten through electrolysis of acidified water, which is electrolysis of water. So, and this preparation involves two processes: liquefaction of the atmospheric air and the fractional distillation of the liquefied air. All right, how do we do the liquefaction of air? To obtain liquefied air, the air is filtered and passed through a caustic soda. Caustic soda is what? Sodium hydroxide, to remove dust and the carbon dioxide. It is then compressed to a high temperature of about 200 atm. Now, by compressing the air, it gives about a lot of heat. It gives out a lot of heat. Now, the compressed air is then cooled and allowed to escape rapidly through a minute jet into a compression expansion chamber. I'm going to show you the setup. The sudden expansion of the air into a region of lower pressure further cools the air. And the cooled air will cool the stream of air coming into the expansion chamber. This process is repeated until all the gaseous air becomes liquid at minus 200 degrees Celsius. So it's been repeated until all the gaseous air becomes liquid in the expansion chamber. All right. After that, what else to be done is fractional distillation of liquid air. The liquid air is then passed into a fractionating column. On distillation, nitrogen, of course, we know, the more volatile one boils out first at a temperature of minus 196 degrees Celsius and is being collected as liquid nitrogen. You know that we are talking about air, and air comprises of both nitrogen and the oxygen and all of that. So similarly, oxygen boils out at a temperature of minus 183 degrees Celsius and is being collected as liquid oxygen. The liquid oxygen is now being compressed and being stored in a strong steel cylinder under a pressure of about 100 atm atmosphere. So this is how it's been prepared in the industry. Okay, this is what we have been talking about. This is the chamber. This is the process, liquefaction and the fractional distillation of air. So this is the distillation, where the distillation is being done. This is for nitrogen gas, and this is the argon, and the oxygen is being found here. First of all, the compressor is here, and after that, it will now pass, be filtered off, and go through this particular final chamber for it to be distilled out. All right, this is the chamber for that, for industrial preparation of oxygen. What are the physical properties of oxygen? Pure oxygen is a colorless gas, odorless and tasteless gas. Next thing is that it's neutral to litmus paper. It does not have acidic or maybe basic alkaline property. It's slightly soluble in water, and gaseous oxygen liquefies at minus 183 degrees Celsius and solidifies at minus 225 degrees Celsius. Now, number 5 physical properties of that is that its density is about the same as that of the air. Its density is as the same as that of the air, and it has some chemical behaviors. What are the chemical behaviors or chemical properties of that? Number 1 is direct combination with other elements. Direct combination with other elements. Oxygen, of course, as a gas, support combustion of many substances. When we hear about combustion, it's combustion, burning, has to do with burning. And the oxygen is what supports burning. So metals except mercury, silver, and gold react with oxygen to form basic oxide. As you can have it here, sodium reacts when it burns in air, it forms sodium oxide. Potassium, it forms burns in air or reacts with oxygen to form potassium oxide. The same thing, calcium oxide. So it supports direct combination with other elements. So combine it any particular element and the oxygen, it will give you the particular oxide you want, the particular oxide of that particular metal. Okay, the oxide of very reactive metals like potassium, sodium, and calcium dissolves in water to form alkalis. You do hear alkalis. Alkalis are just bases, but soluble bases. They dissolve in water to form alkali. Something like potassium hydroxide is an alkali, sodium hydroxide is an alkali, calcium hydroxide is another alkali. But these first two is the potassium hydroxide and the sodium hydroxide. They are more soluble than calcium hydroxide. However, three of them, they are all soluble in water. They are alkalis. Whenever you hear about alkalis, these are the alkalis that you can use as an example. They are soluble bases. They are not the only bases, but they are soluble one. Okay. Next thing we need to understand about the chemical behavior of oxygen is that when sodium and potassium are heated in a plentiful supply of oxygen, higher oxide like sodium peroxide, potassium peroxide are formed instead of the basic oxide. When there is a heavy supply of air, plentiful supply of air, instead of the oxide, it will form the peroxide of it. So that is one of the behavior of this reactive metals. It does that. So another thing is that the non-metals like sulfur, calcium, and phosphorus burn in oxygen to form acidic oxide. So carbon bonds in air, in oxygen, phosphorus bond in oxygen, and sulfur bond in oxygen to form acidic oxide. And this acidic oxide is what we call acid anhydride. What are they, acid anhydride? Because when those acid anhydride, those oxides dissolve in water, they will form acid. They form acid. Look at it. Acid anhydride is sulfur oxide. This one also, phosphorus, carbon oxide, phosphorus oxide is also an acid anhydride. We have it here. So with that, you see that we have several acids that they can form. They can form this one. You can see it can form tetraoso sulfate 6 acid. This one, it can also form trioso phosphate 4 acid. And here we also have, okay, this one is trioso phosphate 2 acid. This is trioso carbonate 4 acid. And these are just acids. These are acids that they form. The acid anhydride. These are acid anhydride. That is one of the chemical properties or behavior of that. Okay. Next thing is this. Okay, this one is for trioso phosphate. What? 6 minus 3. 6 minus 3. Of course, we'll give you 3. Okay. Trioso phosphate 3 acid. All right. Another chemical behavior is this. Most hydrocarbons burn in oxygen to form carbon dioxide and water. Of course, hydrocarbons are known for combustion reaction. When they burn in air, they will produce carbon dioxide. So it's one of the chemical behavior of chemical properties of oxygen because it supports combustion of hydrocarbons. Next one is that oxygen we breathe in oxidizes the carbohydrate we eat to release energy. Glucose, this is the formula for glucose. This is the formula for glucose. So the oxygen we breathe, is what we are saying that it oxidizes, it helps to oxidize the carbohydrates we eat to release energy, break it into carbon dioxide and water. Energy will be released. Another chemical behavior is formation of ozone. Ozone is the three oxygen atom. Three oxygen atoms. So Ozone is an allotropic form of oxygen. It's an allotropic form of oxygen. The reaction of oxygen with elements and compounds are examples of oxidation reaction. An oxidation process in which heat and light are produced is called combustion. Oxidation process in which heat and light are produced is what we call combustion reaction. Combustion has to do with burning, which on it heat will be given and light will also be produced. Okay, how can we test for oxygen? Before we cap up this particular class, how can we test for oxygen in the lab or anywhere? Oxygen is identified by its ability to rekindle a glowing splint. A glowing splint is known for oxygen. Now, nitrogen 1 oxide does this as well, but it distinguishes from oxygen by its pleasant sickly smell, while oxygen is odorless. So nitrogen 1 oxide does the same rekindling of a glowing splint, but it has a very bad pleasant sickly smell, while the other, that of the oxygen, is odorless. It doesn't have odor. That is the meaning. That is the meaning. Oxygen also reacts with nitrogen 2 oxide to give brown fume of nitrogen 4 oxide, which nitrogen 1 oxide does not do so. So these are the differences between two of them in terms of test. If you have a test that rekindles a glowing splint, you can use issue of their odor and testing it with nitrogen 2 oxide to differentiate it, differentiate the two gases. That is what we have done in this particular video. And what are the uses? Oxygen is used as an aid to breathing when a natural supply of air is insufficient. We use it even in the hospital. We use it put to aid someone's breathing when anyone that is having difficulty in breathing. And it is used in oxyetine and the oxyhydrogen flame for cutting and welding metals. You see welders, they use it in their welding processes. Liquid oxygen and fuels are used as propellants for space rockets. Next one is that oxygen is used in the steel industry for the removal of carbon, sulfur, phosphorus impurities from ore. Next thing is that oxygen is used in the manufacture of important chemicals, compounds like tetraoxosulfuric acid, triosonitrate 5 acid, and ethanoic acid. These are the wonderful uses of oxygen. And with this, we'll end to the end of this particular class. But for further discussion and inquiry, remember to get to me through my phone line, +234 80 655 73229, +234 80 655 73229, or you can get to me, send me an email to my email address at christo116@gmail.com. Thank you for being part of this particular class and enjoying it. Get ready for the next video. Make sure that you watch the next video that will come. Thank you and remain blessed.